Radiometric dating with uranium lead or potassium argon cannot be used to date dinosaur bones directly, nor the sedimentary rocks in which they are found. Since the 1800s, dinosaur bones have been assigned ages according to their place in the geologic column. For dinosaurs, that is 65 to 230 million years ago. When carbon-14 dating became available around 1950, dinosaur bones were considered to be way beyond its detection limit of tens of thousands of years, so nobody bothered to test them with it. Carbon-14, or radiocarbon, is considered to be extremely reliable. Its accuracy has been verified by using it to date artifacts whose age is known historically. While an animal is alive, it takes in radioactive carbon-14. When it dies, the carbon-14 decays away over time. The amount remaining tells you how long the animal has been dead. Many dinosaur bones are not fossilized. Dr. Mary Schweitzer, professor of marine, earth, and atmospheric sciences at North Carolina State University, surprised scientists in 2005 when she reported finding soft tissue in dinosaur bones. She started a firestorm of controversy in 2007 and 2008 when she reported that she had sequenced proteins in dinosaur bone. Critics charged that the findings were mistaken, or that what she called soft tissue was really biofilm produced by bacteria that had entered from outside the bone. Schweitzer answered the challenge by testing with antibodies. Her report in 2009 confirmed the presence of collagen and other proteins that bacteria do not make. The reason for the controversy is that all traces of soft tissue should have disappeared by 100,000 years. Likewise, if dinosaur bones are 65 to 230 million years old, there should not be any carbon-14 left in them either. But there is. Members of the paleochronology group are consultants in geology, paleontology, chemistry, engineering, and education, who perform research on fossils. They have now tested samples from many different dinosaur skeletons for carbon-14, and in every case, the dates fall between 22,000 and 39,000 years before present. That easily explains why soft tissue survived till now. Dinosaur bones are much younger than they were assumed to be. The Morrison Formation is a dinosaur graveyard averaging about 330 feet thick that covers much of the central United States with layers of sand, mud, and silt cemented into rock with calcium carbonate, limestone. Its position in the geologic column is late Jurassic. In 1989, a team dug up a skeleton buried just west of Grand Junction, Colorado. It was an Allosaurus, a 40-foot-long carnivorous dinosaur. Here we see an upper hip bone or ilium being uncovered. These are vertebrae, a rib, and a tarsal bone that was part of a foot. A bone sample was sent to the University of Georgia for carbon-14 testing in their accelerator mass spectrometer. The result was a date of 31,360 years before present, plus or minus 100 years. The Hell Creek Formation is another dinosaur graveyard in Upper Cretaceous layers of sandstone, mudstone, and clay, 130 to 560 feet thick. The formation covers a swath across the north-central part of the United States. In 2007, a skeleton was dug up 7.5 miles southeast of Glendive, Montana. It was a very large ceratopsian dinosaur like this Triceratops, but it had an unusual protective frill and its brow horns extended sideways, so it may be a new type of ceratopsid. Over half of the bones were removed from the dig site. They included bones of the front left leg and shoulder blade, the neck, the nose horn, the left femur, part of the protective frill, a left lower hip bone or ischium, and a bone that projects from the shoulder blade called a coracoid. A bone sample from the femur was sent to the University of Georgia for carbon-14 testing in their accelerator mass spectrometer. The result was a date of 39,230 years before present, plus or minus 140 years. In 2004, there was another find in the Hell Creek Formation, this time about 3 miles east of Glendive, Montana. It was from a Triceratops. Only a single femur was uncovered. It was wrapped in protective covering and sawed open. Samples were removed. Testing for carbon-14 at the University of Georgia in 2009 resulted in a date of 24,340 years before present, plus or minus 70 years. Apatosaurus was a sauropod dinosaur. The remains of one was found in late Jurassic strata of the Morrison Formation about 85 miles northeast of Denver. It was partially excavated in 2007 and 2009. An embedded rib was exposed and scrapings were taken to be tested for carbon-14. The sample was sent to the University of Georgia in 2011, and the resulting date was 38,250 years before present, plus or minus 160 years. In 2011, a hip bone of a duck-billed hadrosaur was found near Marmarth, North Dakota, in the Hell Creek Formation of late Cretaceous strata. Scrapings from a bone sample were sent to the University of Georgia. The carbon-14 date is 37,660 years before present, plus or minus 160 years. In May 2012, the brow horn of a Triceratops was uncovered about 6 miles southeast of Glendive, Montana. A bone sample was sent to the University of Georgia to test for carbon-14. It dated to 33,570 years before present, plus or minus 120 years. In 2004, a femur bone from a duck-billed hadrosaur was found about 10 miles southeast of Glendive, Montana in the Hell Creek Formation. It was sawed open in 2005 and numerous samples were taken. The sample sent to the University of Georgia was tested for carbon-14 on their accelerator mass spectrometer and yielded a date of 25,670 years before present, plus or minus 220 years. Acrocanthosaurus was a carnivorous dinosaur. Remains of one were found near Glen Rose, Texas in Cretaceous sandstone and excavated in 1984. A bone sample was sent to the University of Georgia in 2010 for testing, and the carbon-14 date was 29,690 years before present, plus or minus 90 years. Carbon-14 is a radioisotope with a half-life of 5,730 years. The useful limit for accelerator mass spectrometry is normally about 43,000 years. Since 2010, that limit was increased to around 55,000 at the University of Georgia's facility. The dates for all the dinosaur bone samples tested are well below these limits. The researchers took special care to preclude contamination by protecting the samples and avoiding cracked areas in the bones. The Center for Applied Isotope Studies at the University of Georgia treated the dinosaur samples in precisely the same way that they treat any other bone samples from late Pleistocene mammals up to the present time. On each report, they wrote what they did. They cleaned the bone with an ultrasonic bath. The bone was crushed and treated with acetic acid to remove carbonates absorbed from outside the bone during burial. This was repeated 4 or 5 times, the final one lasting over 20 hours. Hydrochloric acid was added in a vacuum to dissolve the bone mineral and release carbon dioxide from bioapatite. Further reactions converted the carbon dioxide to graphite, which was then tested in the accelerator mass spectrometer for carbon-14. The presence of soft tissue and original carbon-14 in dinosaur bones has clearly been established, but scientists don't want to believe it. In 2011, a Swedish team found soft tissue and biomolecules in bones of another creature from the time of the dinosaurs, a mosasaur, which was a giant lizard that swam in shallow ocean waters. They obtained a carbon-14 date of 24,600 years before present, but assumed it must be from bacteria, even though they didn't find any. In August 2012, the Paleochronology Group presented their carbon-14 test results at a joint meeting in Singapore of the American Geophysical Union and the Asia-Oceania Geosciences Society. After the conference, they received a note from the conference chairman. It said, There is obviously an error in these data, and removed the abstract from the conference website. They never made the slightest effort to see the data. It just did not fit the assigned ages for dinosaurs. When they found out about data that was not what they wanted to hear, these so-called scientists moved quickly and decisively to make the test results go away because anomalies are heresy that must be suppressed. This shameful attitude is common among leaders of modern science, yet the news media trusts them completely. So the only way you can find out about it is here on the internet. By contrast, actual scientists are eager to discover the unexpected, to learn, adapt, and advance human understanding. Fortunately, the group's abstract is on the conference CD that was given to each of the more than 2,000 scientists in attendance. Accelerator mass spectrometry is a technique to measure isotopes that has dramatically improved the ability to detect tiny amounts of radiocarbon in samples. It was first used for this in 1977. The sample is vaporized, the components are ionized, and the ions are accelerated with a magnetic field. The trajectory of the ions bends depending on the mass of the ions. So by adjusting the strength of the magnetic field, you can select isotopes of interest. Even if other molecules have the same mass, there is no molecular interference with AMS. The different elements in a sample are detected and counted because each has a particular mass-to-charge ratio. The paleochronology group has shown that dinosaur bones contain measurable amounts of carbon-14. It is time for others to get involved. Collections of dinosaur bones are in museums and universities around the world. Carbon-14 testing should be conducted on these as well as on bones found in new excavations. The Glendive Dinosaur and Fossil Museum in Montana has already taken the lead. When will the rest follow?